pair solutions, integers, to this equation. A squared plus b squared is equal to 1,807,000. Now, that would be a circle centered at the origin of a radius of about 1,000, which doesn't really help us much here. Now, let me make sure this notation here, this congruence notation, says that any integer upon division by 4 is going to leave a remainder of 0, 1, 2, 3, or 4. And just basic arithmetic, if you divide by 4, your only possible remainders are 0, 1, 2, or 3. Now, just as an example here, let's say if we talk about x congruent to 3, and again, it's understood that it's mod 4 right here. That means the very same thing. In fact, you can put an if and only if arrow if you want to. That means the very same thing as saying that x is equal, not congruent, but equal to 3 plus some multiple of 4. And that really makes the remainder part kind of stick out like a sore thumb. So there we go. And I could write down a similar statement for 0, 1, or 2. Okay, m's another integer here. Okay. Now remember, we are looking for all ordered pairs that are solutions to this equation right here. Now, so 0 and 1 are easy. 0 squared is still 0, and 1 squared is still 1. So we're going to look at x congruent to 2. Now, x congruent to 2 mod 4 gives us this. X squared is congruent to 2 squared, and 4 is congruent to 0 mod 4 because 4 divides 4 minus 0. In a similar fashion, x squared, if x is congruent to 3, then x squared is congruent to 3 squared, and 3 squared is equal to 9. 9 is equal to 1 plus 2 times 4. So notice that what happens here is something that's quite helpful here. What we get, and that's why this mod 4 is useful for this kind of problem, we get any integer x squared is going to be congruent to one of two values, namely 0 or 1. And so I'll put 0, 1 here. And of course, we are talking mod 4. Now, mod 4 is kind of, there's not a lot of possibilities. I guess that's why it's popular. Okay, so any square number is only leaves a remainder of 0 or 1, which is interesting all by itself. Now, what does that do for us as far as this problem goes? See, what that does, though, is if you look at all the possible combinations right here, if a squared can only be 0 or 1, and if b squared can only be 0 or 1 mod 4, then that would mean that a squared plus b squared which is what we're interested in, can only be congruent to the various combinations you get when you add 0 and 1. Okay? So, of course, if they're both congruent to 0, you would get 0, right? If one is congruent to 0 and the other is congruent to 1, you get 1. If both of them are congruent to 1, you get 2, right? And again, that is mod 4, folks. And again, this is for all a, okay? There's not an exception to this. Any integer you think of, this is for all a. That's the universal quantifier for all a member of the integers. And integers are just the natural numbers and their negative counterparts along with 0. Okay. Okay, so that's a pretty telling fact as far as this problem goes, because remember, we are trying to solve this equation right here, right? Now, what we do here, and it's really a fairly easy problem, notice that when you divide 4 into this number, 1,807,000, you do get a remainder of 3. Now, remember, this means the very same thing as 1,807,000. Okay, would be congruent to 3, right? And that's the 3 you see right here. That's that 3. That's the remainder, right? And there's a multiple of 4 going on in here, so it's mod 4. And how are we supposed to interpret that? Well, we just found out from above that the sum of two squares has to leave a remainder of 0, 1, or 2 mod 4, right? Okay, but we just, for this particular choice of numbers, we get something that is is congruent to 3 mod 4, okay? So that means it's very clear that there's no solution here, okay? Because again, this guy right here is congruent to 3, all right? And we've just shown that all pairs of integers, when you sum their squares, is congruent to 0, 1, or 2. So the answer is no solutions. There are no answers, okay? No solutions. What it is, it's a circle centered at the origin with no integer valued points. Okay. So a little, I don't know, maybe a misleading question. Okay, there's no solution to this equation. Okay. And I always feel a little guilty about these kind of problems, folks, because the way the problem's worded, it says find all. Well, that says some people might interpret that, well, there are some, but it just says find all of them, but there are none of them. So I think it's fair. And if you word it any other way, it's kind of a giveaway. So I defend my position. Okay. Hope you guys like that one.